Hey, I'm Mr. Bork, and welcome to today's presentation on slope. This is a big deal, slope. Okay, so, in order to define what slope is, we're actually just going to talk about it for a second. So, you may probably, and I hope, have at least seen somebody skiing or snowboarding or something like that. You probably heard them say things like, oh, we're totally going to hit the slopes today, man. Well, what are they talking about? Well, they're talking about the hills that they're going to ride down. And obviously, that there is a big difference if you decide to go down, oh, I don't know, let me get my paintbrush, a hill that looks like that, or if you decide to go down a hill that looks like this. There's a big difference. So basically what the slope is, it's a number that's used to describe how steep something is. So I can say, though, this is not very steep, and I can say that this is very steep. Well, this number didn't just come out of, like, nothing. Like, they didn't just be like, all right, that hill, that looks like a 2. Okay? No, there's an actual way to measure the slope. And you actually kind of can realize what it is very easily using some very basic ratios. That's what we're doing. So I'll draw a couple pictures to help us illustrate how to find what the slope actually is. So here is my excuse me. Here is my snowy mountain. Okay, right here, snowy mountain. And at the top of our mountain is pro snowboarder Shaun White. And here's his snowboard, and this looks pretty bad, so let me make it a little bit more realistic. Alright. Shaun White, there we go. And if you didn't know, he had red hair. Okay. Anyways, what Shaun White is concerned about right now is probably two things. Well, I hope. He wants to know how long is he going to be sliding down this hill for? Or basically, a way to think about this, how long horizontally is he going to travel? He's probably wondering that. And he's probably also wondering, how far down is he going to go? That's probably wondering a little bit more about that one. Well, these are just two numbers, right? A horizontal distance, and I'm just going to call that x for reasons maybe relating to the x-axis. Okay? And he wants to know how far down he's going to go, and I'm going to call that number y because maybe it relates to, I don't know, the y-axis. And the slope is a ratio that compares the y to the x. It compares those two values. Okay, and you can see that for different hills, there's a big difference. So Shaun White decided to go down a bunny slope, is what we call this, like a baby slope. And here's baby Shaun White on his snowboard. Wait, baby Shaun White. So, ding. Alright, here's baby Shaun White on his snowboard. Baby Shaun White is also concerned with the same two things. Okay, what's the horizontal distance? Wow, that's really bad straight line. What's the horizontal distance, and what's that vertical distance? The y and the x. And there's definitely some kind of difference here. These do not look the same. So that's basically what slope is. It's a vertical change. Okay, so change in y, vertical change, divided by a change in x, a horizontal change. And I'm sure all of your math teachers in the whole wide world, and even maybe in different language, will say rise over run. Because when you think about it, rise is a vertical change. It's like if you're in an elevator, you rise up and down. And run is a horizontal change. If you're running across a room, you're running like across the floor. You don't run like straight up into the air. So it's rise divided by run. How much does it rise by? How much does it run by? So let's take a look at some examples. Let's see if we can find the slope given like a graph or maybe some points. We could do that. So we're going to need a graph. So abracadabra, graph. So we got a graph here, and we want to find the slope of, let's say, you know what? I'm just literally drawing two random points. I'm drawing from right here to, let's say, right here. And I want to know the slope of that line. And I will try to draw the straightest line that I possibly can. It's a pretty bad line, so just stay with me here. Alright, so I know that there are 2 points on this line, and what I'm going to be doing is I want to count the rise and run between them. So let's say I start at this point right here. Well, in order to get to this point, I have to count rise over run. I'm not allowed to move diagonally. I can only move up and down, left and right. So when I say rise, in order to go from here to here, I have to rise, well, down 1. That seems kind of weird. It's a rise of down 1. Well, if I go down on a graph, that's like saying I went -1. So the rise would be -1, and the run, we'll do in blue, I'm going to run over 1, 2, 3. I ran over 3 spaces. So I rose -1, and then I ran, and I'll make that in white there, and I ran 3. So the slope of that line is -1/3. That is the slope of that line. And I could say, you know what? No, I'm going to start at this point, and then I'm going to go up to this point, like kind of walking up the hill. So I rise up 1. So I went up 1, and then I ran. I have to go backwards this time. I'm going backwards 3. Well, if I went backwards 3, that's a -3. So that's the same thing. -1/3 is the same thing as 1 over -3. The slope is -1/3 of that line. And that's how you find slope between 2 points on a line. Now, what if we didn't have the graph? What if we just had 2 points? So, vanish graph. What if we just had 2 random points and I wanted to know the slope between them? We could do that. Here's my 2 points. Let's say I have 5, 3, that's one of my points, and my other point is going to be 7, -2. Well, remember, slope is the change in y divided by the change in x. So what I'm looking for is the change in the y values divided by the change in the x values. So if I'm talking about that, I can say, and I'm going to write this down first, then I'll explain what it means. y2 minus y1 divided by x2 minus x1. And that's for any given points. If I give you a point, some x1, y1, and all that means is that the x value comes from this first point, and the y value comes from that first point. And here's my second point, like I've given you here, x2 and y2. And all that means is the x value from here comes from the second point, the y value comes from the second point. So given any 2 random coordinates like this, I can plug them in. I can find the difference between the y values, divide it by the difference between the x values, and I'm going to have the slope. And this equals m. We use m for the slope. So let's find out what it is for this example. So I'm going to label these real quick. Okay, so that's x1, that's y1, x2, y2. And I can actually switch that around. I could actually say that this is x2, y2, x1, y1. And you could test it out on your own. See if you get the same answer as what I'm about to get here. All right, so y2 is -2. Okay, and then y1 is 3. So y2 minus y1, -2 minus 3. Cool. Divided by x2, which is 7, minus x1, which is 5. Well, let's see what we get. -2 minus 3, well, that's -5. And 7 minus 5, that's 2. So my slope is -5/2. And we're not going to write that as a mixed number. We like our slope as improper fractions that are simplified. So that's the slope, -5/2. And what does that mean? Well, let's say we're talking about feet. Okay, what this would mean is you have to drop down 5 feet and then run over 2 feet. Okay, for every 5 feet you have to drop down, you have to run over 2 feet. That's what it means. That's the slope. Okay, it's a ratio of vertical change over horizontal change. It's pretty awesome, I'm not going to lie. So that's how you would find the slope between 2 points. Now, what does all this have to do with anything? Well, it all helps us do something with graphing linear equations. We can graph equations with 2 variables. Okay, and this is actually incredible. This is like you're taking numbers and variables and you're turning it into a picture, which is pretty awesome, if I might say so myself. So let's say we have, you know what, how about y equals -1/2 x plus 3. And what I've done here is I've written this in a special format. Okay, and that special format is called the slope-intercept form. The slope-intercept form is y equals, and I'll use some different colors here, m x plus b. Well, what in the world? Well, m is your slope. I should probably use blue. So, m, that's your slope. So whatever's in front of x, the coefficient of x is the slope. And b is your y-intercept. Whoa, I didn't use that word before. What's y-intercept? Well, y-intercept actually is a very easy thing to know. Y-intercept is basically where your line, because this is going to be a line when we graph it. We could remember in the last lesson we made a table of values. We picked some random x values, and we plugged them in, and we made this chart by connecting the dots. We made a line by connecting the dots. So this is going to be a line, and B represents where that line is going to cross the y-axis. So it's called the y-intercept. So abracadabra, boom. We got ourselves a graph. Let's see what happens here in this example. So we've got 3 as our y-intercept in this example. Right there. 3 is our y-intercept. So what that mean? Well, it means that the line, I don't know where it is on here, but I know it's going to cross at 3 on the y-axis. And take a look. Here's the slope, -1/2. And that's telling us what to do. Remember, slope is rise over run. So rise -1. So rise -1 from the y-intercept. We rise -1. That means go down 1. And then run 2. So we go down 1 over 2. All you need is 2 points to make a line. So there you go. That's our line. And I'll try to draw that as neat as I can. And that's it. We just graphed an equation that was in slope-intercept form. It's pretty exciting, I have to say so myself. So let's just do one more, because these are so cool. And here, let me clear up some space real quick. All right, let's say I have, how about y equals -5/7 x. And that's it. Okay, well, remember, what I'm looking for is I'm looking for y equals mx plus, whoa, that came out all weird. I'm looking for y equals mx plus b. Well, where's the b? I don't see him. So, actually, he's there. B is 0. Okay, you don't have to write a +0, so that's where b went. It's 0. Not there. It's nothing. So let's get a graph, because it looks like we have everything we need to graph. Abracadabra. All right, so the b is 0, so that means the y-intercept is 0. The line's going to cross the y-axis right there at 0. And the rest of the line, let's take a look at what it looks like. Okay, so from the y-intercept, it says rise -5. That means go down 5. 1, 2, 3, 4, 5. And then run 7. So I'm going to have to count this the best I can. Run 7. That should be right there. And we've got our 2 points, and we can make our line. Oof, that is this messy line, but it works. And there we go. That's it. That line is the same thing as y equals -5/7 times x. That line represents all the solutions of that equation that has 2 variables. I think it's pretty awesome. And we use slope to help us determine how to graph that line. We'll talk more in the next lesson about what slope actually means in the real world. What in the world does this have to do with anything? Okay, it's for right now, it's just to make some cool pictures of some lines if you think that's cool, which I do. Okay, but we'll talk about more in the next lesson about what does that actually mean. All right, I'm Mr. Bork, and that was slope.